Okay, thank you very much. So this needs a bit switching gears after the break. Well, of course, before the break, more about research being done and on, say, infrastructures and technologies, which somehow need to be there in order to be able to carry out this research. This is now more about, say, the underlying technologies and infrastructures. And it's not only about HPC, it's also about, say, how to store data and how to provide also, say, and use cloud technologies to simplify the access to these kind of resources. So let me start from, say, a top-down approach and start with, say, what are the concepts behind, say, an IT, distributed IT infrastructure, which we call Fenix. And I mean, you will probably recognize, say, a few of the things which have been, say, mentioned earlier, particularly also in Jan Julich's talk. So what we, say, are putting in place is a set of infrastructure services which can serve multiple communities. So it is in particular including, say, the brain research community. And we do that by, say, having this kind of layer approach, as it is shown in this picture, where you have the users from the different communities here in the top. And they are not necessarily directly accessing the infrastructure services. So basically think about it as being, say, more the bare metal, but they are using, say, platform services like the ones which are putting in place by eBrains. So it is about, say, providing a federated infrastructure services to support then platform services. And that is basically the part I'm talking about that is here at the bottom, where we have different infrastructure services, where infrastructure services can be compute services, can be data store services. And what we, say, want to achieve here is that while all these services are provided by different sites, that they are federated. So we also need to have services which allow or facilitate this federation, so that you have, say, an uniform access to these services. And what it buys you also is what we call a composability of these services. So it's not this classical approach of an HPC center providing, say, a large-scale system, and then you submit jobs via a batch queuing system. It is about providing, say, a set of different services, which you then can combine in different ways, possibly even, say, distributed over different sites. And you have already in Katrin Amund's talk seen a very brief example of how things can actually be extended over different sites. And the last important aspect is that we are not looking for, say, a unique implementation of these services, because it's very important to make sure that you're not entering into a technology or vendor lock. So that is something which we carefully try to avoid. So now let's look what are the kind of services which we try to put in place. Now let's start with, say, the computing services. And that obviously includes also, say, things like, say, scalable computing services, which is about high-performance computing, but it's also about adding new types of services which are not necessarily so typical in today's infrastructures, like having, for instance, interactive access to HPC systems, and also to have it tightly coupled with more cloud type of compute services, like, for instance, the service to host virtual machines. Then there are the data services. I will explain later what it means in terms of having, say, different types of data repositories. And it's not only about providing data repositories, but it's also providing services which allows them to locate data or to move then data between these different data repositories. And then finally, we have, in order to federate that, we need common authentication and authorization infrastructure, and we have to find the ways of how to actually manage the users in the system, to manage projects there, so that we can, say, for instance, assign resources to a project and in a distributed infrastructure, and to also track on what kind of resources are being consumed if, say, a project is not using only resources at one site A, but maybe also at the site B. And that is, say, a very high-level picture. So you have the different types of compute services, you have different type of storage services, and they are, of course, then interconnected by networks, possibly, say, very fast networks. So now getting more concrete. So currently, we have 5 supercomputing centers which are involved in this building up the Fenix infrastructure. And they are, as you can easily see from this list, they are very much distributed all over Europe, starting from the Barcelona Supercomputing Center in the south of Spain in Barcelona, then having, say, the French Supercomputing Center near Paris, the Italian Supercomputing Center in Bologna, the Swiss Supercomputing Center in Lugano, so close to the Italian border, and then in Germany, the Julich Supercomputing Center is involved where I'm coming from. Now, even so we start from supercomputing center, I think it's always important to stress this is first of all not meant to be, say, a closed club. So we, say, deliberately design things in a way that it can be extended, and it can also be extended to non-supercomputing sites. So that really depends on the kind of services which are required. It's just how things also evolved. Now, you might ask the question, I mean, why is it beneficial to actually have a distributed e-infrastructure? Because it adds a lot of complexity, right? I mean, it would be sometimes much simpler, I mean, to have everything on one side. Now, there is, say, for most, the aspect of having data locality. In particular, in the Human Brain Project, we have, say, a number of projects which are producing tremendous amounts of data. So we're talking here about petabytes of data. And you don't want this to be, say, just moved around, right? I mean, even though we have fast networks, I mean, they have their limitations, and so it is much more preferable to have the data processing done where the data is actually also available. Then you can also, in certain cases, think about making services available at different sites, and in this way, your availability will increase. Then certainly, when, say, putting infrastructure in place at different locations, you will also see a larger diversity of the provisioned services. So at the 5 different sites, we are not going to put in place, say, exactly the same, say, infrastructure. It's conceptually the same kind of services, but behind it, the implementations are different. So it includes, say, in part, say, smaller clusters, which are more, say, useful for having, say, distributed tasks. But it also, for instance, at CSCS, we'll come back to this point later, includes a tier 0 supercomputer. So where you can scale out simulations to thousands of nodes. Then one thing, I mean, not to be underestimated, I mean, like in many other advanced technology fields, experts are scarce. So being able to pool experts and to have different kind of expertise at different sites is also, say, an important benefit. And the last point which I would like to highlight is also the sustainability of the overall infrastructure. Even so there is a certain amount of diversity, I mean, there's also quite a significant amount of similarity of, say, the services which are provided by a different site. So if for whatever reason, because funding stops, one site has to drop out, it will be possible to plug in another site, and it does not necessarily affect, say, the user's view. So this helps to, say, sustain the overall effort. Now let's look in some of the services in a bit more detail, starting with the compute services. Now, as already highlighted, I mean, we continue to provide, of course, what is our core expertise as supercomputing centers to provide scalable compute services. So this is for scalable jobs, like, for instance, simulations, where you can, say, you're not using only one node, but use maybe, say, even thousands of nodes in order to address very large-scale problems. And one of the things which we hope to also add at some point, that there's a certain amount of elasticity also in there, which is something in capability which we don't have as of today. Then there's something new which you don't find, say, in typical HPC centers, that are interactive compute services. So that's basically the ability that you just can log into a single server, have then, say, the view on all your data so that you can interactively process your data, and maybe also use interactive frameworks like Pleiter notebooks. And then finally, say, the virtual machines. So this is really about putting, like, you know, say, from cloud providers to allow users to put their fully customized environment onto virtual machines and have them as such, of course, full control. Now, this is not necessarily, typically not for an end user, but this is meant to, say, deploy platform services. Now, next to data services. Here we decided conceptually to make a distinction between two types of data stores. And the first one are, say, the archival data repositories. And their important feature is that they are going to be federated and allow for sharing of data. So they are meant to hold file data products, to also hold them over longer periods of time, and they are going to be accessible through a Swift interface and are integrated into an AI. Now, for those who are familiar with, say, object stores like Swift, but also think about Ceph, know that these are, say, not data stores which you want to access from a massively parallel HPC systems. It would be way too slow. That would be not a good idea. So that's why we introduced basically a second type of storage, which we call active data repositories. There you can hold private copies of your data, and you have then data mover services, which allows them to move data between these two different worlds. And that is, say, also shown here in this picture. So down here, an archival data repository with a Swift interface from where you can have a federated access. Then you have an active data repository, which typically we translate into a parallel file system, as those who have been using HPC systems so far know. And from here, you can then, with a high performance, connect to scalable compute services. And you have a data mover service, which, say, allows to move data between these two different worlds. And in the interactive computing services, because there we are not in the highly parallel world, we can allow to access both types of data repositories. Now, how does it look like with the federation of these services? And that's where it becomes, say, technically and also organizationally, say, most challenging, is how do we facilitate that users who have access to one of the sites can have access to any of the other sites. And there has been, say, a lot of experience, say, collected with that in say, a world which is called, say, the World Wide Grid. In particular, say, LHC has done, say, quite some pioneering work. But the solutions where they came up were essentially, say, to some extent, proprietary solutions. And there's now, say, a trend, and that's what we now also following in terms of the high-performance computing centers, is to use standard industry protocols. Right, so that we are, say, compatible also what is done in industry and follow there the technology development. And our approach is here that we say, okay, we trust, one of the challenges which you have here is that for a user which gets assigned with a virtual identity, how can we be sure that this virtual identity indeed belongs to a user? I mean, we could go, say, for Google as an identity provider. At least there is a supposed relation with, say, a cell phone number that gives you, say, at least a little bit of trust. But it's certainly not enough, I mean, in order to give you, say, access to very valuable and partially also export restricted technologies. So that's where we have also in the future to be, say, careful about that. So that's why we decided, okay, we trust basically the identities which are provided by the supercomputing center, and then these ones are federated, but we also allow for other identities, but maybe not for all kinds of operations. Then what we secondly need is to also have the ability to manage users, to understand is a user, for instance, part of a certain community, to manage, say, resources, but also to be able to store additional attributes for a user. So that is, for instance, important to manage, for instance, access control to the data, which is a key aspect when you are, say, sharing data in a federated infrastructure. And for this, we put, say, something in place which we call, say, the Fenix User and Resource Management Service, which is then together with the AI and a central proxy for the identity providers, say, the key components for, say, the federation of this infrastructure. Now, one thing which I would like to highlight, and I will come back to it at the end, is so far, whatever I have presented are, say, very generic concepts, right? It's not, say, something which we do very specific by the community, because it is supposed to service also different kinds of communities. So far I have talked about concepts, and now let me take you through, say, some of the things which are already in place as of today. I will not take you, given the amount of a little time, in all the details of this graph. It just shows you that in practice, if you look at an HPC center, say the implementation can be quite complex, but you might still recognize some of the components which I was talking about earlier. So for instance, here you have at CSCS large-scale supercomputer. So that is the one which provides scalable compute services. It actually also allows to then use it for interactive compute. You just get allocated with a single node. Through the internal network, you have then access to all kinds of data repositories, including then also the ones which we then label as being active or archival data repositories. And you have here an OpenStack cluster, which allows you then to deploy VMs. So in this sense, you can see in a concrete implementation, you can find back, say, the conceptual elements of the architecture presented earlier. So looking at even more concretely, I mean, what we currently say can offer to the users is access to, say, the fastest, according to the top 500 metric, computer which we have in Europe, Pitstein, which comprises of two types of nodes. There is on the one hand the Pitstein multi-core partition, where you have nodes where each node has 2 CPUs. And there's actually the larger partition, which is called Pitstein hybrid, where each of the nodes comprises of 1 CPU and 1 GPU. And since there are, say, more than 5,000 of these, I mean, this gives you, say, enormous, say, compute power in the tens of petaflop. And you can see here in this picture that's actually not 1 node, it's actually 4 nodes. So you have here 4 CPUs and 4 GPUs. And on top of that, there are, of course, active data repositories in terms of a Lustre parallel file system and an archival data repository, which is accessible through a Swift interface and allows people then to store petabytes of data. So with all these resources in place, the question, of course, arises of how do we make these resources available and how is this allocation process? And for this, we introduced a concept which we call Fenix credits. A Fenix credit is, you can also think about it as a kind of a voucher for, say, consuming resources. And each credit has essentially 4 attributes. It is valid only for one site. So it's not, say, a universal currency and you can, say, easily exchange it between different sites. Otherwise, for us, planning of resources would be, say, become very difficult. Then it is for, say, a given class of resources, for instance, scalable compute, interactive compute, VMs, or different types of data stores. It has, of course, a value, and it has a validity period. So, of course, what you don't want to have as a structure operator is that a project gets a lot of Fenix credits, waits until the end of the project, and then wants to consume everything, right? I mean, so here we mandate that there is some reasonable consumption of the resources over the time. Now, these credits are provided by us as resource providers to communities. And how much it is, that depends on, say, the funding scheme. And I will come back to what it means in the case of the Human Brain Project. And it's then these Fenix communities which have to decide which projects are getting these credits, right? That's not the business of the resource providers. So this is something where we are very careful in delegating that. And the way of how, at least currently, this has to be done by these communities is by means of a peer review process. So in order to make sure that these very expensive resources are used in the best possible way. And it's then up to the community to have a process in place which allows them to determine whether a project is indeed excellent. Now, this is not, say, our decision. I mean, this is basically something which is mandated by the funding agency, which wants to get, say, value for, say, the money which is invested. You could, in future, also, say, think about different kind of mechanisms of how this is actually done. I mean, there's virtual access models, there are pay-per-use models. So these kind of things might come. I can only, say, reflect what is, say, the current state. And specifically from the infrastructure which we have in place right now, we as resource providers are obliged to provide 25% of the resources to the Human Brain Project. That may be not only, say, the members within the Human Brain Project, but also, say, other neuroscientists, but it's essentially the allocation mechanism is run by the Human Brain Project. Another 15% goes to PRAISE and is through that mechanism distributed at European users at large. And the remaining 60% are then distributed to local users through national mechanisms. They are typically all with the same kind of principles, meaning that based on a peer review, judging about the excellence of a project, resources get be assigned. So finally, let me quickly, since I have 0 minutes, quickly take you through 2 examples to really show also what is, say, the benefits of having, say, this composability of these different resources. So one of the first things we currently have running is a simulation of a hippocampus. And at the end, it's not only about, say, the simulation, which requires, say, scalable computing services, but you have to also analyze the resulting data, where you need an interactive services. You have to store the final data product, and then you might want to offer access to this final data products then to users through, for instance, web-based visualization services. So to give you a summary and outlook, so Fenix is a very generic concept to provide, say, access to e-infrastructure services, and it can, say, service multiple communities. We have now an initial infrastructure running and also the allocation processes in place so that researchers can apply for resources. Currently, the service portfolio is provided by 5 supercomputing centers, but in order to stress it again, in the future, we expect other, say, resource providers to join, and we also hope that other types of resources will be included into this infrastructure. Thank you very much.
Thank you very much, Dirk. I wonder if we have time for one question, and other questions would be kept for Q&A session afterwards.
Very quick one. So where should I go right now to get the resources?
It depends a bit on currently, I mean, we have to distinguish whether you are in HPP or whether you're outside of HPP. So for within HPP, I can give you an email address. We have a very short, you can also find it on the Fenix website, say in description, and pointers to where you find in the collaboratory also templates for, say, writing, depending on the amount of resources you're asking for, a very short or maybe a little bit longer application, because somebody has to judge about what is the excellence of the project. For PRAISE, we and this is actually a continuous call, so you can basically submit a proposal at any time. For PRAISE, there will be 4 times a year, there will be calls, and the call is now basically about to open it every day, any day. There was a bit of a shortage in personnel in the PRAISE office in Brussels.